Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, step 2, step 3, step 4, and your challenge is to determine the number of line segments in step 5. If you can do that, can you determine the number in step 43? And can you write an equation that can be used to determine the number of segments in any step at all? That's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, so this is kind of interesting. I guess, it looks like kind of an orb made out of line segments, and it's just getting wider, right? So there's these sort of two halves here of the orb, and then we put this 3 by 1 in the middle, and then there's two of them, and then there's three of them. Aha! So I'm thinking in step 5, we would have a 3 by 4 orb. There'd be 4 of those threes. So like that, plus that same pattern here. So there and there and there. And then same on this side. Okay, so I think we could count the segments if we don't get too confused there. Actually, I kind of want to think about these two side pieces and then the middle. So in the side piece, 1, 2, 3, 4, 5. So there's 2 of those. So if we exclude the side pieces, if you want to just get rid of those, so anyway, this is a 5 and a 5. Let's think about what's left in the middle. This is a 3 by 4 grid. How many segments does it take to make a 3 by 4 grid? Well, I think I'm going to count the horizontals first and then all the verticals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That makes sense. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So 31 plus 5 plus 5, that is 41 line segments. What do you think? Did I do that correctly? So I'm guessing 41, but let's go ahead and analyze the numbers and we'll see if that 41 makes sense. So we'll put the step number and the number of segments. And actually, before we get these numbers on here, what's your prediction? Is this linear? Is it quadratic? Is it something else? And what makes you say that? Why do you guess what you guess? All right, well, let's do our counting here. So in step 1, I think we just have 10 because we've counted. That's the 2 side pieces, right? So we can verify that. 1, 2, 3, 4, 5, 6. Oh, wait, we don't have 10, do we? Because we have the center line. Aha. So we have these 10 plus 3 in the middle. Right, so that should be 13. Let me count this again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, I'm getting 13 there. All right, and then now let's think about what we're actually doing each step. So we can think about this part being there and this part being there. And then that first line was there. So what we're really adding is just this kind of shape. It looks like this. So that's what we're adding. And that's actually, I think, what we're adding every step, right? So how many segments is this? 1, 2, 3, 4, 5, 6, 7. So it looks like this should be 20. And then 3 would be 27. Let me just double check that really quickly by hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Yeah, this is working out the way I thought it would. Okay. So, and in step 4, we're going to have 34. Pause and count if you want to double check me on that. And then in step 5, we're predicting 41. And you might already be leaping forward to an analysis here, which leads you to an equation. We're going to do this by taking the differences here. 20 minus 13 is 7. 27 minus 20 is 7. 34 minus 7 is 7. And 41 minus 34 is 7. And that makes sense. We're adding one of these every time. So we're adding 7 line segments. This is a constant, so our equation is linear, our pattern is linear. We can use this equation for a line, and that change in each step goes in for the slope. So y equals 7 times x. And then the plus b we can determine from step 1. We have 13. If I put in 1 for the step number goes in for x. So 7 times 1, that would just give me 7. I need 6 more to get to 13. So b is 6. Let's test this really quickly with a couple other steps. So y equals 7 times 2 plus 6. 14 plus 6 would be 20. That's what we've got in step 2. How about in step 3? 7 times 3 plus 6, that's 21 plus 6 would be 27. Yeah, looks like that's working. So our equation is y equals 7x plus 6. And now we can determine the number in step 43 by just plugging in 43 there. So y equals 7 times 43 plus 6. And let's see, 7 times 43, 7 times 40 would be 280, plus 21 would be 301, plus 6 would be 307 line segments in step 43. Well, how did that go for you? A little tricky trying to count all those segments. Did you get 41 for step 5? Did you end up with this equation? Let me know. Thanks, everybody.